Hi, my name's Seth, and I've been teaching the GMAT with test crackers for a long time now. I'm doing this series on the 10 toughest problems in the problem-solving section of the latest official guide because these problems contain within them a lot of the tools that you're going to need to solve all the problems that GMAT can throw at you, and because they contain the principles that will guide your use of those. We're moving to this one now. Seed mixture X is 40% ryegrass and 60% bluegrass by weight. Seed mixture Y is 25% ryegrass and 75% fescue. If mixture X and Y contain 30% ryegrass, what percent of the weight of the mixture is X? Somebody over at GMAC thinks that it's cute or funny to mess with us by throwing stuff like fescue in here that we have never heard of. And that can be a little intimidating because you think, do I need to know what fescue is to answer this problem? Short answer, no. In the past 10 years of seeing this problem, I have never once even bothered to look up and find out what fescue is. It's totally unimportant to this problem. And most of the words that might show up on the GMAT that you don't know are totally unimportant. To reduce the way in which I even think about them or acknowledge them, I tend to just abbreviate them. So I'm going to refer to fescue as FU from now on, just to make life easier. So in this case, the key to reading the problem through is ignore FU and focus on the rest of it and say, what type of problem am I dealing with? I've got a mixture of this seed and this other seed. Sounds like a mixture problem. And as you may have seen in some of my other videos, mixture problems mean weighted average, and weighted average means part A plus part B is going to equal part of A times B. Note that all my formulas, when I can, I'm going to express without a denominator, so not as a division problem, but as a multiplication. And this is just saying however much of the stuff I care about times however many things I have in quantity A, plus however much of the thing I care about times however much quantity I have of B is going to equal however much total percent I have of A plus B. This will work for anything that we care about. Could be profit, could be grades in 2 classrooms, could be all kinds of things. In this case, it's some type of grass seed, which is a bit of a stretch to include in the category of things I care about. However, I do for answering this problem because it says what percent of the weight of the mixture is X. And the mixture is 30% ryegrass. So I'm wondering the percent of the mixture that's X. Good habit to write that up on the board. And I'm thinking the final mixture is 30% ryegrass. So I'm thinking it's going to be 30% here. And then I think, well, going back, the first one, seed mixture X, so that's X. We don't know how much of it we have, so we're stuck with a variable. Seed mixture X is 40% ryegrass, okay? 40% ryegrass. And seed mixture Y, note I'm ignoring the bluegrass because the thing we care about is ryegrass. That's what we're told about that. That's what's here and here. We can ignore bluegrass and we can ignore FU for this entire problem. So 40% of mixture X is ryegrass and 25% of mixture Y is ryegrass. So 25 over 100 times Y is ryegrass. And together we're going to end up with 30% of our final solution, which of course is the mixture of X and Y, so the quantity is just going to be X plus Y. This has allowed us to set up an equation pretty quickly out of the problem. Now we need to solve it. And some of you will note we have 2 variables here. And you're right, we're not going to be able to solve for either of them individually. Does it ask us though? Does it actually ask us what X is? It doesn't. It says what percent of the weight mixture is X. So it's really X over the total that we care about. And so that's what we're going to be looking for. And we will be able to get that because we know the total is X plus Y, so we want to know X over X plus Y. We're really just looking for a ratio of X to Y, and so we'll dig that out of here. Okay, next step. As always, we start by multiplying by 100 just because all these disappear, so we can just deal with numerators. And we continue by saying 40, 25, and 30 sounds like 5 is a common factor, so we can divide by 5, we'll get 8, 5, and 6. Now let's see what we got. 8x plus 5y is going to equal 6x plus 6y, if I just distribute that 6 on through there. And let's cluster our like variables. We'll subtract 6x from each side and subtract 5y from each side. And so we end up with 2x over here equals y. So we got to subtract 5y there, 6x, right? Do the same to both sides. 2x equals y. I've got a fork right now where I can go to a lot of different routes to figure out what percent of the total mixture is x. And so it's going to depend on you. One option is to think about this as an equation. And for those of you who like algebra, you just say, well, do I have another equation? And if I want to know what percent of the total, I really want to know how much out of every 100. That's what a percent means. And so I could just say, well, this is one equation, 2x equals y. Another equation is x plus y equals 100. If I solve these, that'll get me there. And I could move this over. I could say 2x minus y equals 0. And I could add these two equations. 2x plus x is going to be 3x. Minus y plus y goes away. 0 plus 100 just equals 100. I know 3x equals 100, so x equals 100 divided by 3, or in other words, 33.3 repeating percent. Or as a fraction, approximately 1/3 of the mixture. That's one way to answer it, and that'll get us what we need. Answer choice B. Split I talked about. We know 2x equals y. Another way to think about this is to create a ratio. And so if we divide both sides by 2y, we end up with the 2's cancel here and the y's cancel here. X over y equals 1 over 2. This is a part-to-part fraction. We're saying for every 1 unit of x, we have 2 units of y. That's what that tells us. And if you know the key to fractions and to ratios, it's to realize that there are 3 facts anytime you divide things up. At least, there's a part, another part, and a whole. And so we can talk about 4 out of every 5 dentists recommend a certain thing, and that's a fraction, part to whole. Or we can say, for every 1 doctor who doesn't recommend it, there are 4 who do. And that's a part-to-part relationship of 1 to 4. And those things have to add up because 1 to 4 to 5 is part to whole. In this case, saying we have a ratio x to y of 1 to 2 means our ratio of x to y, 1 to 2, is going to be part of a same total of 3. And if you lay all these out, you've got all the facts on board. We can think, okay, so 1/3 of the mixture is x, 2/3 of the mixture is y, and the ratio is 1 to 2 of x to y. So keep that in mind. That's another way that you could do this, and just knowing 1/3 is 33% would also get you the answer there. Both of these are good approaches. I've got one tip here that I saved for the end because it tends to confuse people, but there is another way to do this. It's even easier on a problem like this, and it's about saying that anytime you have a weighted average, you can actually kind of visualize where you need to be. Because we've got these two things, and this one is 40%, and this one is 25%, and our goal is to end up at 30%, right? And if we just kind of put these on a number line, should have put them in the opposite order, you'll notice something, which is that the end result, 30%, has to be in between 25 and 40. Because if all we used was seed mixture Y, we would just have 25% ryegrass. If all we used seed mixture X, we would just have 40% ryegrass. And so to get 30, we're going to have to use a little bit of this and a little bit of that. If you map this out on a number line, where you put 25 for one of them, and then you put 40 for the other, and then you put 30 in the middle there, you think, well, where does that really fall between 25 and 40? And if you think about equal chunks, it's not right here, because you can say, okay, 25, 30, 35, 40, that's what equal chunks look like. And our target is right here. We're trying to be right there. Well, the way a weighted average works is that the more you weight one side, the more it tips you in that direction. And so rather than being all the way tipped to 25 or all the way tipped to 40, or exactly halfway in the middle, which would be what if we had equal quantities of mixture X and equal Y, mixture Y, we're saying we're at 30, which is right here. And so we can think, how does that look as a fraction of this total distance, right? You're saying, well, 40 minus 25 is 15. So there's 15 units in between one mixture and the other. And where we're ending up at 30 is 5 of those units away from 25. Or you could say it's 10 of those units down from 40. And either one of those is enough to get you the same fact we wound up with without doing any of these calculations. How so? Well, think about it. If we're saying if all we had was mixture X, we would just be at 25%. We're saying once we start adding 40, that's going to pull us up from 25. And if we want to get pulled up 5/15ths of the distance, or in other words, reduce that to 1/3, that means that 1/3 of the mixture is going to need to be this 40% solution. Or we could think about it the other way. If we start with all 40% and we want to go 10/15ths of the distance down to the 25% solution, well, that reduces to 2/3. And so we're saying we need to go 2/3 of the way to 25. And so to go 2/3 of the distance, we need 2/3 of the mixture to be 25% solution. And 1/3 of it remaining, but is the 40%. So that's this quick visualization, and for some people that's a great time saver. For other people, it's a great way to get these problems wrong. And that's why I save it for the end. Knowing this formula is much more reliable. And that's a good lesson overall for the GMAT. Anytime you have the choice of trading speed and accuracy, it's not worth it. You want speed in certain ways, and again, in a good course, you'll learn a lot of strategies to help you manage speed, but you never want to give up accuracy for speed, because it's not worth it. Getting the wrong answer is just infinitely worse than getting the right answer a little bit more slowly. Okay, so circling back, what are the principles, what are the goals on this one? First of all, once again, recognize a mixture. Or, slash unequal combination average. And that formula is your formula. You know how to use it. Next step. Reduce before you multiply. RBM, reduce before you multiply. It is always going to be worth it to save that effort when you're going through something like this. Number 3, remember, ratios equal part to part fraction. Right? And know how to use those to get the relationship between ratios, percents, and fractions. All of these ideas show up in lots of GMAT problems. You want to be really comfortable using them. And then finally, last one here is, remember, there's the visual shortcut. And for some people, that visual shortcut will be worth the time it saves if you're really comfortable in using it. For other people, don't let it get you to the wrong answer. And it's really easy to get turned around on this, I'll be honest. I've seen a lot of people use this and end up with the wrong answer because you just think about it wrong. The key to using it right is to remember you start at one end and you're wondering what fraction of the distance you're going towards the other, and that's the fraction of the total mixture that will be composed of the other end. So if we start at 25 and we're going 1/3 of the way to 40 up here, that means that 1/3 of this total mixture can be the 40% ryegrass mixture of seeds. All right, thanks for sticking with me and running through this problem. I'm doing this series on the 10 toughest problems in the GMAT official guide problem solving section, and I'm doing it to give you the tools you need to solve these and other problems, and the principles that help guide you and save you wasted effort. If you want a way more in-depth and interactive version of this kind of stuff, check out our courses at Test Crackers. We keep them small. We go over all the stuff you need to succeed. We have a lot of office hours where you can ask questions from the homework, and that's the kind of stuff that's really going to make the biggest difference for a lot of people. But for others of you, hopefully this is plenty. Either way, if you did find this video useful, like and subscribe. There's going to be more like it coming down the road for you. I want you to have access to those. Comment if you have questions or anything. I'll try and respond to those comments and kind of keep you in the loop. And generally, good luck in your studies.